Welcome you all to session 2 of the chapter Ray Optics. In the last session, we have learned the types of spherical mirrors. Spherical mirrors are of two types. One is concave mirror and another one is convex mirror. In this session, we will be learning how actually the image is formed by spherical mirrors. There are some rules we need to understand so that we can find how actually the image is formed by the spherical mirrors. Okay, let us learn the rules one by one. Let us go with the rule number 1. Okay, the first rule says that if the incident ray is parallel to the principal axis, if the incident ray is parallel to principal axis, then the reflected ray passes through principal focus. Okay, this is the rule number 1. If the incident ray is parallel to the principal axis, then the reflected ray passes through principal focus. Okay, let us check it out with the ray diagram. Okay, first let us consider a concave mirror, then I will be considering convex mirror. Okay, we know that this is a concave mirror whose reflecting surface is inside the curve. So let me take this point as the pole, and this is the line which passes through the pole, and this line is called as principal axis. Let me take here, there is a pole, midpoint of the mirror is called as the pole, and the axis which passes through the pole is called as principal axis. Okay, now let us say the incident ray is parallel to principal axis. Okay, let me take, this is a ray which is parallel to principal axis. This is called as incident ray. After reflection, the ray should pass through principal focus. Okay, where is principal focus? Let us understand. Okay, let us imagine this is a sphere and this is the center of curvature, and we have studied in the last class that principal focus will be exactly at the midway between center of curvature and the pole of the mirrors. Okay, now if the incident ray is parallel to principal axis, then the reflected ray passes through principal focus. If the incident ray is parallel to principal axis, then the reflected ray passes through the principal focus. Okay, this is in case of a concave mirror. Let me take a convex mirror and let us check it out. Okay, this is the convex mirror whose reflecting surface is outside the curve. Okay, this is the principal axis and this is the pole, and let us imagine a sphere. If I imagine a sphere, there is center of the sphere is its center of curvature, and exactly at the middle there will be principal focus. Okay, let me take, if the incident ray is parallel to principal axis, let me take the incident ray which is parallel to principal axis. Now, what does a convex mirror do? It diverges the ray, right? It diverges in such a way that it appears to come from principal focus. Okay, if the incident ray like this, the divergent ray appears to come from focus, right? So this is how the ray which is parallel to principal axis behave, right? Once again, if the incident ray is parallel to principal axis, then the reflected ray passes through principal focus. This is rule number 1. Okay, let me go with the rule number 2. Now the second rule, let us check it out. The rule 2. This is rule 1. Okay, if the incident ray passes through principal focus, then the reflected ray will be parallel to principal axis. Okay, just the reverse of this. If the incident ray passes through principal focus, then the reflected ray will be parallel to principal axis. Let us check it out. Okay, let me take this for both the mirrors. Let me start with the concave mirror. This is concave, whose reflecting surface is inside the core. That is called as concave. Okay, this is the principal axis. Okay, this is the center of curvature. Exactly at the center, there will be principal focus. Now, if the incident ray passes through principal focus, let me take an incident ray which passes through principal focus. Okay, let me take this. This is the incident ray which passes through the principal focus. Okay, where actually the reflected ray will be? The reflected ray will be parallel to principal axis. Okay, which is principal axis? This is principal axis, and the reflected ray will be parallel to principal axis. Okay, this is the rule number 2 now here. Okay, this is for concave mirror. Let us go with convex mirror now here. Okay, the same rule. Let me go with the convex mirror. Okay, this is the convex mirror, and here the reflecting surface is outside the core. Okay, let me take. This is the principal axis, and let me consider this is a center of curvature and this is the principal focus. Okay, what does the rule says? If the incident ray passes through principal focus, okay, let me take now here. If the incident ray is like this, right? If I am considering the incident ray, if the incident ray is like this, right? So if the incident ray passes through the principal focus, then where will be the reflected ray? This is incident ray. It cannot pass through it because it is a mirror now here, right? Okay, where will be the reflected ray? Reflected ray will be parallel to principal axis. Okay, when it falls like this, the reflected ray will be parallel to principal axis. Right? This is the second rule. Okay, the first rule says that if the incident ray is parallel to principal axis, it passes through principal focus. If the incident ray passes through principal focus, then the reflected ray will be parallel to principal axis. These are reverse of each other now here, right? This is rule number 2 now here. Okay, let us go with the third rule now here. Okay, let me move on to the third rule. Rule 3. Okay, let me take like this. Rule 3. Okay, third rule, what actually it is? Let us check it out now here, right? If the incident ray passes through, if the incident ray passes through center of curvature, if the incident ray passes through center of curvature, then the reflected ray retraces the same path. This is rule number 3. If the incident ray passes the center of curvature, then the reflected ray retraces the same path. Okay, let us take with ray diagram now here. Once again, this is a concave mirror whose reflecting surface is inside the curve. Now let us check it out. This is a spherical mirror. This is center of curvature. Exactly at the center, there will be a principal focus. Now where is the incident ray? Incident ray passes through center of curvature. Okay, let us check it out. This is center of curvature. If the incident ray passes through center of curvature like this, right? This is the incident ray which passes through center of curvature, then the reflected ray retraces the same path. Means again it retraces the same path. It moves in that line itself. Right? This is rule number 3. Okay, let us take this in case of convex mirror. Okay, let me check it out. This is the convex mirror whose reflecting surface is outside the curve. This is the principal axis. Let me take like this, and this is the center of curvature, and exactly at the mid there will be principal focus. Now where actually the incident ray passes through center of curvature. Okay, now this is the incident ray. Let me take now here incident ray like this. This is the incident ray which passes through the center of curvature. Where will be the reflected ray? It retraces the same path, right? Okay, means it retraces the same path. Okay, this is rule number 3. If the incident ray passes through center of curvature, then the reflected ray retraces the same path. Now let me go with the rule number 4. Okay. This is rule number 3. Let me go with rule number 4. If the incident ray falls on the pole of the mirror. Okay, let me take like this. I am speaking about mirror itself. If the incident ray falls on the pole, then the reflected ray obeys law of reflection. See, if the incident ray falls on the pole, then the reflected ray obeys law of reflection, right? Okay, then the refracted ray follows or obeys. Then the reflected ray follows law of reflection. Let us check it out. First, let me check it out with the concave mirror. This is concave, whose reflecting surface is inside the curve, and this is the principal axis. And we know we have to imagine a sphere, and this is center of curvature. Exactly at the mid there will be principal focus. Okay, where is the incident ray now here? The incident ray falls on the pole. Let me take like this. It falls exactly on the pole here, right? If the incident ray falls on the pole of the mirror, right, then if this angle is theta, right, the reflected ray will be like this, and the angle made by the reflected ray with the principal axis will be theta itself. That is what it is stated there. The reflected ray follows law of reflection. What is the law of reflection? Angle of incidence must be equal to angle of reflection, right? If it falls exactly at the pole, so this is the pole now here, this is angle of incidence is theta, then angle of reflection must be theta now here, right? So angle of incidence will be equal to angle of reflection, right? The reflected ray follows law of reflection. Okay, let me go with the second mirror, that is convex mirror. This is the convex mirror, right? Okay, this is the principal axis now here, right? Okay, this is the pole, and we know that the reflected surface is outside the curve now here. The reflecting surface is outside the curve, right? Okay, this is the pole. Let me check it out. When a ray of light falls at the pole now here, right? If the incident ray falls on the pole, then the reflected ray, again it follows the law of reflection itself, right? So if this angle is theta, and this angle will be theta, right? So this is incident ray and this is reflected ray. Okay, these are the rules which are used to find where actually the image is formed by the object, right? Image formation by spherical mirrors. There are 4 rules. First rule says, if the incident ray is parallel to principal axis, the reflected ray passes through the principal focus. Second rule, reverse of that, if incident ray passes through principal focus, the reflected ray will be parallel to principal axis. Third rule says, if the incident ray passes through center of curvature, then the reflected ray retraces the same path. If the incident ray falls at the pole, then the reflected ray obeys law of reflection. So these are the rules to find where actually the image is formed by spherical mirrors. Let me take an example, and let us check it out how actually the image is formed by the spherical mirror. Okay, let me use these rules and find where actually the image is formed if the object is in front of the mirror. Okay, let me take like this. See, let me check it out. Let me take example by taking a concave mirror. Okay, this is a concave mirror whose reflecting surface is inside the curve. Concave, right? This is it is a part of a spherical surface, and we know this is the principal axis, and the center of the sphere is the center of curvature. Just it is an imaginary. Let me remove it. Right here there is center of curvature. Okay, here exactly at the center there will be principal focus, and this point is the pole of the mirror. Okay, if a person is standing here, right, let me take a person is standing here now, right? If the person is standing here, where actually the image is formed. Okay, shall I use the 4 rules now here? Okay, the first rule says if the incident ray is parallel to principal axis, then the reflected ray passes through the principal focus. Let me use that. Okay, this is the ray. Always the ray comes from the object. Okay, this is the incident ray. Okay, this is the incident ray where actually the reflected ray goes now here, right? It passes through the principal focus. So this is the first one. If the incident ray is parallel to principal axis, the reflected ray passes through the principal focus, right? Okay, now there is another one rule. What happens if incident ray passes through center of curvature now, right? If incident ray passes through center of curvature, what happens? If incident ray passes through center of curvature like this, right? If incident ray passes through center of curvature, let me draw a straight line here. This is the center of curvature. Okay, if incident ray passes through center of curvature, this is the way, right? If incident ray passes through center of curvature, where is the reflected ray? It retraces the same path. Okay, so this is incident ray, it retraces the same path. Okay, let me use another one rule. What happens if incident ray passes through principal focus, right? Okay, what happens if incident ray, let me take like this, if incident ray passes through principal focus, this is the incident ray which passes through the principal focus. Okay, if incident ray passes through principal focus, where will be the reflected ray? It must be parallel to principal axis. Okay, let me take, where is principal axis? This is the principal axis and it must be parallel to principal axis. This is the reflected ray, right? Okay, so here just check it out, all these lines meet at a point itself. Okay, let me go with another one. What happens if incident ray falls at the pole of the mirror now here? Okay, let me take, where is the pole of the mirror? This is the pole of the mirror. Okay, if incident ray falls at the pole of the mirror, okay, according to rule, the reflected ray follows the law of reflection. Okay, if this angle is theta, then it should move in such a way that that angle, the angle of reflection must also be theta. Okay, this is the rule. And if this is theta and this is also theta, right? Okay, this is if the incident ray falls at the pole of the mirror, then the reflected ray follows the law of reflection. Okay, one thing what we need to observe here is the rays which come from the object after reflection meet at a point, and that point gives the image, right? Okay, let us check it out. So this is the image of this, means the image will be like this, right? This is the object and this is the image. We find the inverted image in case of concave mirrors, right? Do you understand? The rays which are emerging from the object after reflection meet at a point, then that point is the image of the object, right? Okay, and another thing what we need to understand here is if the reflected ray meet at a point, then the image is real image. If the reflected rays appear to meet from a point, then the image is virtual image. Okay, images are of two types, real image and virtual image. Okay, when actually the real image is formed, real image is formed when the reflected ray meet at a point. Virtual image is formed when reflected ray appears to meet at a point. Okay, we will be seeing such kind of examples in further session here, right? Okay, here what you need to understand, we have followed all the 4 rules and we calculated where actually the image is formed by this object after reflecting from the concave mirror. So this is how the image is formed by the concave mirror. Now let us move on to the next section, that is mirror equation. Okay, first of all let us understand what actually the mirror equation is. Okay, the relation between object distance, image distance and focal length of a mirror is called mirror equation. Okay, simple. What is mirror equation? It is the relationship between object distance, image distance and focal length of a mirror is called mirror equation. Let us check it out like this, right? First of all, you should understand what actually the object distance is. Okay, we have seen in the earlier case that this was a concave mirror and there was an object like this. This was the object which I took now here, right? Okay, and we got the image in this position, right? This was the thing what we have seen in the earlier ray diagram now here, right? Okay, if this is the object, what is the object distance? Okay, we know that the distances are always measured from pole, right? We have studied under the sign conventions. In sign conventions, we know that the distances are always measured from pole. Okay, where actually is the pole now here? This is the pole, right? So this is a concave mirror and this is the pole now here, right? Okay, what is object distance? It is the distance of the object from pole, right? Okay, from pole, this is the distance. Okay, this distance is called as object distance, right? Let me take like this. This is the distance. This distance is object distance, and object distance is denoted by u now here, right? So the distance of the object from the pole of a mirror is called object distance. Okay, where is the image distance? Simple, distance of the image from mirror. Okay, where actually from the mirror? From the pole now here, right? Because distances are always measured from pole. Okay, where is image distance? Okay, this distance is image distance, and image distance we denote it by v now here, right? Object distance we denote by u, image distance we denote it by v, and focal length we denote it by f, small letter f, right? Okay, what is mirror equation? It is the relationship between u, v and f, right? The relationship between object distance, image distance and focal length of a mirror is called a mirror equation. Now let me derive the mirror equation. Okay, let us check it out. So what is the relation between these three? Let us check it out, right? That we'll be learning under the section derivation of mirror equation. Okay, let me derive. Okay, now in order to derive this equation, let me take a concave mirror, right? Okay, let me consider this is a concave mirror. Let us check it out here. This is a concave mirror. What is concave mirror? It is a mirror whose it is a spherical mirror whose reflecting surface is inside the curve. That is the name cave, right? Okay, this line, what is this line here? This is the principal axis. And if I imagine a sphere, right, I will be getting a center of curvature here, right? Exactly at the center, I will be getting the principal focus. Now, let me check it out. Let me take an object now here, right? Usually, we take an object like this. Okay, let me consider this is the object, right? This is object. Let me take AB. Let AB be the height of the object, right? Let me take object. Okay, how to find where actually the image is formed? We have the rules. Let us follow the rules and find where actually the image is formed. Okay, rule number 1. If the incident ray is parallel to principal axis, then the reflected ray must pass through principal focus. Okay, let us go like this. Let us take, this is the ray which is parallel to principal axis, where actually the reflected ray must be. It must pass through the principal focus. So this is the way, right? It passes through the principal focus. Okay, let me take another one. Let me take, if the incident ray passes through center of curvature, right? Okay, what happens? If incident ray passes through center of curvature like this, wherever the reflected ray, it retraces the same path, right? It retraces the same path. Let me take like this. Now, let me take where actually the image is formed. If the incident ray, let me consider like this, if the incident ray falls at the pole of the mirror, right? Let me take that. This is the pole of the mirror, right? Okay. If the incident ray falls at the pole of the mirror, right? Okay, let me take like this. If incident ray falls at the pole of the mirror, right? Where actually the reflected ray go? Reflected ray follows law of reflection, right? And it must pass through this point itself, right? If the incident ray falls at the pole, the reflected ray follows the law of reflection. Okay, let me draw it neatly. Okay, let me take like this. the incident ray falls at the pole, right? If the incident ray falls at the pole, the reflected ray passes through this point now, right? It follows the law of reflection. If this angle is theta and this angle will be theta. Okay, we got where actually the image is formed. Image is formed here. Where is the image now here? This is the image. A, B is the object, and let me take A dash and B dash. This is A, where actually the image arrow is. Let me take this A dash, and this is B. Let me take B dash. Okay, what is the object now here? AB is the objector. What is the image? A dash, B dash is the image, right? Okay, let me consider. Okay, we have followed the rules and calculated where actually the image is formed by this object. Okay, let me continue with the derivation here, right? Let me write, consider a concave mirror. Okay, which mirror did I consider now here? Concave mirror. Let me write which mirror did I consider. That is concave mirror. Consider a concave mirror. Okay, first of all, we know we are deriving the equation for mirror. So it is a relation between object distance, image distance and focal length. Let us write which distance is called object distance. Let me write like this. Let me take object distance. Come on, tell me which is the object distance here. Where is object? AB is the object. Shall I call BP as the object distance? But distances are always measured from pole. So shall I say like this? PB is object distance. Okay, shall I take like this? PB is object distance, right? So BP, PB, both are same, but in order to take sign convention, I will be mentioning like this, but both are same here, right? So PB is the object distance. Come on, tell me, is it positive or negative? The question is like this, right? We have studied in the sign convention that if the distances are taken in the direction of incident ray, then they are taken as positive, otherwise they are taken as negative. Come on, tell me now. What is incident ray? Incident ray is denoted by U. Is it plus U or minus U? Let me check it out. The distances are measured from pole. Okay, I am measuring the distance from P to B. Means I am going opposite to the incident ray. Means shall I take plus or minus? Minus. So that is why shall I take what is PB now here? It is minus U, because the distance which are measured from the pole, this is the direction opposite to the incident ray. According to sign convention, I need to take it as minus. So what is object distance? Minus U. Next, let me take what is image distance. Come on, tell me, what is image distance? It is the distance of the image from pole. Okay, where is image? This is image, right? Distance from pole means P B dash, right? Shall I take like this? P B dash, that is image, right? P B dash, right? So image distance is, we denote it by V. The question arises, is it positive or negative? Okay, once again the rule, distances are always measured from pole. From here I am measuring, and this distance is opposite to the incident ray. Then shall I take it as minus U, right? What is image distance? That is minus V, right? Next, shall I go with focal length? Okay, what is focal length? It is the distance between principal focus and pole. Okay, where is pole? This. Where is principal focus? F. Okay, what is focal length? PF. Shall I say like this? PF is the focal length. Now the question arises, is it positive or negative? PF. I am going opposite to the direction of incident ray. Again, focal length is also negative. Come on, tell me, what is focal length? PF. PF is focal length, and shall I take it as minus F? The relationship between object distance, image distance and the focal length of a mirror is called a mirror equation. Okay, let me find what are the relationship between these three, U, V and F. Okay. Now, in order to find this relation, let me take some triangles now here. Okay, here let me take like this. Let me take triangle A dash B dash F. Okay, let me take like this. Since triangle, which triangle? Small triangle. Just check it out. A dash B dash F. This is the triangle which I am considering. A dash B dash F. This is the small triangle which I am considering, right? So this is the small triangle which I am considering. A dash B dash. Another one is F. Okay. A dash B dash F and triangle. Okay, let me take name here it as M now here, right? Okay, this triangle which is at FMP. Okay, FMP. Okay, these two triangles are similar, right? So which are those triangles? A dash P dash F, this triangle and this triangle. What is that? FMP. Okay, let me take like this. FMP. This is the triangle and this is the triangle. Okay, how are these two triangles? They are similar triangles, right? Since triangle A dash B dash F and FMP are similar, if two triangles are similar, then the ratio of corresponding sides are equal. Okay, let us check it out. What are corresponding sides? The corresponding side of B dash F is FP, right? The corresponding side of B dash A dash is MP, right? The corresponding side of hypotenuse A dash F is FM. So these are corresponding sides. We know that if two triangles are similar, then the ratio of corresponding sides are equal. Okay, let me go with the first one. B dash A dash. Shall I take like this? B dash A dash divided by the corresponding side of B dash A dash is MP. MP, that will be equal to B dash F. Shall I take like this? B dash F divided by corresponding side of B dash F is FP. Let me take FP, right? See here, B dash A dash divided by MP. Corresponding side of B dash A dash is MP, right? Then B dash F divided by FP. Corresponding side of B dash is FP. So B dash F divided by FP. Okay, here we are following the rule that if two triangles are similar, then the ratio of corresponding sides are equal. Okay, now let me take like this. Shall I write this equation like this? B dash A dash divided by. Shall I write in place of MP? This MP is nothing but AB, right? The distance MP is equal to AB. In place of MP, shall I write AB? That is equal to B dash F divided by FP, right? Just I replace MP, right, with AB now here, right? Shall I say like this? So instead of MP, I have written AB because MP is equal to AB. Okay, let me take, this is equation number 1. Okay, I took these two triangles. Now, let me take other two triangles now here, okay? Instead, okay, shall I write here? Similarly, again, let me take another one, two triangle. Since triangle, let me take a bigger triangle over here. ABP. Let me take this triangle. Triangle ABP and triangle ABP. This is the triangle. Then B dash A dash P. B dash A dash P are again. What are these now here? Similar. Okay. Let me show here. This is the triangle. Okay, which is the triangle ABP, right? Another triangle is here. This is the triangle, which is that B dash A dash P. Okay, again, let me follow the rule. If two triangles are similar, then the ratio of corresponding sides are equal. Come on, tell me now, by seeing this, what is the corresponding side of AB? P dash A dash. What is the corresponding side of AP, hypotenuse? A dash P, and BP is common here, right? Okay, now shall I say like this? Okay, let me start. Ratio of AB, shall I take like this? AB divided by corresponding side of AB is B dash A dash, B dash A dash, that is equal to, okay, BP, shall I take like this? BP divided by, what is the corresponding side of BP? B dash P dash, B dash P, okay, sorry, BP is B dash P, okay, so B dash P corresponding side is BP, right? BP and B dash P are corresponding sides, right? Okay, now let me check it out here. Here we have B dash A dash divided by AB. Here we have AB divided by B dash A dash. Okay, in order to relate, let me take the reciprocal of this now here. Okay, let me take the reciprocal. What do I get? B dash A dash divided by AB. That is equal to reciprocal of this is B dash P divided by BP. This is equation number 2. right? Okay, just I took the reciprocal of this, right? So b dash a dash divided by ab is equal to b dash p divided by bp. Okay, why did I take like this? Because I need to correlate these two equations, right? From this equation 1 and 2, here also we have b dash a divided by ab, there also we have b dash a divided by ab. Okay, from equation 1 and 2, let me correlate these two things now here. Okay, now let me take like this. If I want to solve now here, let me make a space here and let me continue the derivation. Okay, let me take like this from equations 1 and 2. Okay, this is one equation and that is two equation. Okay, from equation 1 and 2, b dash f divided by fp is equal to b dash f divided by fp is equal to b dash p divided by bp. B dash p divided by bp, right? So both are equal now, right? Since these sides are equal now, right? Left hand sides are equal, then right hand sides also must be equal now, right? Okay. Now one thing, b dash f. Where is b dash f? Okay, this I completed now, right? B dash f. Okay, one thing here. Shall I write like this, right? Instead of b dash f, shall I take like this? B dash f can be written as b dash p minus fp, right? Because always the distances are measured from pole. Here also we have pole, here also we have pole, here also we have pole, here we don't have pole. Let me write in a such a way that it consists of pole, so that we can write the distances now, right? Okay, means where is the distance? B dash f. Okay, once again see here, b dash f can be written like this, b dash p minus fp, right? So that we get b dash f. Okay, b dash f can be written as, once again, b dash p minus b dash p minus fp divided by fp is equal to b dash p divided by bp. Okay, now everything is related to pole here, right? Now I can substitute now here. Come on, tell me, what is b dash p? What is b dash p? Where is b dash p? This b dash p. What is this? This is image distance, right? This is image distance, right? What is image distance? Minus v. Shall I write like this? Minus v. Minus, what is fp now here? Fp, focal length, right? Where is fp here, right? Fp, what is that focal length? Minus f, because I need to take the sign convention, right? Minus f divided by, what is fp? Again minus f. This is the same now, right? That equal to, come on, tell me, what is b dash p? Where is b dash p? B dash p. Okay, image distance, right? I took here. What is b dash p now here? B dash p, that is minus v divided by, what is bp? Where is bp? bp, this is object distance, right? Okay, where is bp now here? This is bp is nothing but pb now here, that is equal to minus u. Shall I take it as minus u? Okay, what do I get? Minus v, minus into minus, plus f divided by minus f, that is equal to, okay, this minus minus will get cancelled. Shall I take now here v divided by u, right? Since we have here a minus sign, let me multiply with minus to all terms in this side now here. I will be getting with v minus f divided by f. Okay, I multiplied with minus to each terms, right? That is equal to, what do I get? V divided by u. This can be written like this. This can be splitted, right? So let me take now here v by f minus. V by f minus. What is f by f? F by f is 1. Shall I take like this? Okay, that is equal to, what do I get? V divided by u, right? Okay, let me continue here, right? V divided by u. If I am continuing this, let me write here. Okay, what do I get? Let me take v by f minus 1, right? It is like this now here. Instead, if you know, f divided by f. Shall I take like this? Okay, what do I get now here? V by f minus 1 is equal to v divided by u. Now I will be dividing all terms by v. Okay, shall I take this? If I divide it by v, v will get cancelled, right? So let me take like this, dividing by v, right? All the terms I will be dividing it by v. What do I get now here? If I divide by v, v will get cancelled. 1 by f minus, if I divide by v, 1 by v. If I again divide by v, v will get cancelled. What do you get? 1 by u. Okay, shall I send to that side? 1 by f is equal to 1 by u, that side, plus 1 by v, and this equation is called as a mirror equation. Okay, what is mirror equation? 1 by f equal to 1 by u plus 1 by v, right? What is f? Focal length. What is u? Object distance. What is v? Image distance, right? The relation between object distance and image distance and focal length is called as mirror equation. So what is mirror equation? 1 by f equal to 1 by u plus 1 by v. Okay, this is how we derived mirror equation. In the examination question will be asked like this: derive mirror equation, right? So I have to concave mirror and derive this equation, that is 1 by f is equal to 1 by u plus 1 by v. Remember this equation, and this equation is called mirror equation. Now let us move to the next thing, that is linear magnification. Magnification means it magnifies, right? It becomes big, that is called as magnification, right? We are speaking about linear magnification, means we are speaking about magnification linearly, means height wise. Okay, first of all let me define what actually linear magnification is. It is the ratio of height of the image to the height of the object See here, the ratio of height of the image to the height of the object is called linear magnification. What is linear magnification? It is the ratio of height of the image to the height of the object. That is called as linear magnification. If I say like this, right? If the object height is this much and image height doubles, then the linear magnification is 2. Means the height of the image is double than that of height of the object. Means how much the height has been changed, that can be calculated if we calculate linear magnification. Okay, once again, linear magnification is the ratio of height of the image to the height of the object. Let us calculate how to get the height of the image and height of the object. How to calculate that? Let us check it out. Once again, let me take a concave mirror. Okay, this is a concave mirror whose reflecting surface is inside the curve, right? Okay, this is the pole. Sorry, this is the pole now here, and this is the principal axis. Where is center of curvature? Here is center of curvature. Where is focus now here? Exactly at the middle now here, right? And let me consider this is the object now here. Okay, let me consider the principal axis, and this is the object, right? Okay, now let me consider what is the height of the object. Let me take HO, right? Let HO be the height of the object. Okay, what is the object? Let me take object is AB, right? How to find the image? We have the rules. Let us use the rules and find the image of this object. Okay, first rule: the incident ray is parallel. Where must reflected ray go? It must pass through principal focus, right? Okay, it will pass through principal focus. Second rule: if the ray of light passes through center of curvature, okay, where must the reflected ray go? It retraces the same path. Means we got already the position of object distance now here, right? Okay, what if the ray falls at the pole now here, right? Once again, let me take like this: the incident ray falls at the pole. The reflected ray obeys law of reflection, right? It obeys law of reflection, and it will pass through this now here, right? Okay, where is the image now here? This is the image, right? A, let me take A dash. Here it is B. This is B dash. Okay, what is object now here? This is object. What is image? This is the image. What is the height of the image? Let me call the height of the image as HI, right? Let HO be the height of the object and HI be the height of the image. Then what is linear magnification? HI divided by HO, the height of the image to the height of the object. The ratio of height of the image to the height of the object is called as linear magnification. HI divided by HO. Now let us find how to calculate this. Now let me take the two triangles. Okay, let me take like this. Since triangle, okay, I took this earlier derivation, I took these triangles A, B, P. Let me take this triangle, bigger triangle A, B, P, and triangle, this triangle, smaller triangle B dash, A dash, P, right? Okay, what is that now here? B dash, A dash, P. Okay, see here. ABP, this triangle, bigger triangle, and B dash A dash P, these two triangles I am considering. Okay, we know what is linear magnification, height of the image divided by height of the object. What is the height of the image here? This is the height of the image. Shall I take like this? B dash A dash. Okay, we know that. Since these two triangles are similar, if two triangles are similar, then the ratio of corresponding sides are equal, right? Okay, let me take this B dash A dash. Shall I take this? B dash A dash divided by the corresponding side of B dash A dash is AB. Shall I take like this now here? AB. What is this? This is nothing but a linear magnification, right? So B dash A dash is height of the image, AB is height of the object, right? Okay. So that will be equal to, shall I take like this? That will be equal to, now just think it over, there are two triangles. Okay, which are those two triangles? So one is this triangle. What is that? ABP, right? And the one triangle is, this is the triangle. What is that now here? A dash B dash P. Okay, first what did I take? B dash A dash divided by AB, corresponding side. Now, shall I take this one? This side? BP. What is the corresponding side of BP? B dash P. What is corresponding side of B dash P? BP. Shall I take like this? B dash P divided by BP. Corresponding side of B dash P is BP. Right? Okay. These two are equal. Come on, tell me now here. Shall I take like this? B dash A dash divided by AB is equal to B dash P divided by BP. Okay, come on, tell me. What is B dash A dash? B dash A dash is height of the image. How do they represent height of the image? HI. Come on, tell me. Is height positive or negative? This height is negative, because again we need to go with the sign conventions. If the height is downwards, take it as negative. If the height is upwards, take it as positive. Okay, shall I tell you this? What is B dash A dash? B dash A dash is height of the image. But what is that now here? Minus. Divided by, what is AB? Height of the object. Shall I take HO positive or negative? Positive. Why? Because it is upwards. HO, that is equal to, shall I take like this? B dash A dash is height of the image, HI. Since it is downward, I took it as minus H dash divided by HO. What is B dash P, man? B dash P, it is the distance of the image from the pole, that is image distance. Do you understand? It is image distance. Okay, B dash P or P B dash. Since the image, the distance are always measured from pole, and since I am taking opposite to the incident ray, it must be negative, right? This is image distance, we denote it by, since we are taking opposite to the incident ray, we are taking it as minus, divided by, what is BP? BP is object distance. Distances are measured from pole. From here I am measuring, but this is opposite to the incident ray. Shall I take plus or minus? Minus. So shall I take it as minus U? Right? Okay. These two will get cancelled now, right? If I am taking minus and minus, these two will get cancelled. What do I get now here? Minus HI divided by HO is equal to V divided by U. Right? Okay, but I don't want HO, just I want HI divided by HO. Shall I take like this? Minus V divided by U. What is HI by HO? This is nothing but M. What is M? M is called as linear magnification. Okay, what is the linear magnification? Linear magnification, the formula we got now here, right? So this is the linear magnification. Linear magnification, it is the ratio of height of the image to the height of the object. Right? So instead of finding the height of the image and height of the object, by knowing object distance and image distance, we can calculate the linear magnification, right? Linear magnification has two formula now. One, HI divided by HO, another one is minus V divided by U. Image distance divided by object distance, right? So in order to find the linear magnification, we actually want height of the image and height of the object. If we don't have height of the image and height of the object, if we have object distance, image distance, we can calculate the linear magnification, right? Linear magnification, M is equal to HI divided by HO, that is equal to minus V divided by U, and this is the equation for linear magnification, right? That is the ratio of height of the image to the height of the object. Shall I say like this? HI divided by HO is equal to minus V divided by U. So this equation is called, this is the equation for linear magnification, right? This was all about reflection of light. In the next section, we will be starting with refraction of light. Thank you.